Hi guys, today we're gonna do a Battleship game in JavaFX, and this is what it will look like. So you'll have two boards. Player board is underneath, and you have enemy board on top. To the right side, you'll have controls, and we'll deal with controls later, probably in the next tutorial. First of all, you start off by placing ships. Left click will place the ships vertically, and right click will place them, so left vertically, right horizontally. Currently you'll have 5 ships. Each ship will be of length 5, 4, 3, 2, 1. So we can place ships like that. Once you've placed all your ships, you can now shoot the enemy board, and whenever you click, the cell will become black, or the color of the cell. If you hit the target or a ship, so basically the cell's color will become red. Same thing with your board underneath. So you can keep clicking as long as you hit part of the ship. You're allowed to continue your move. And as soon as you miss, the enemy will be able to shoot on your board. The enemy that we have right now is very naive AI. It basically chooses random cell and then shoots. That's basically it. So there are many possible extensions, but we'll first cover the basics, and then we'll see how that goes. You can either create a new project or use the tutorials project and create new package. We'll have 3 classes: class ship, board, and battleship main. This will be the application class. So we'll start off with ship because it's the easiest one. We just import parent. Ship extends parent. Type is the length of the ship. You can call it whatever you want as long as it makes sense. Vertical is the boolean that has information about the orientation of the ship. So vertical position means from top to bottom, and horizontal from left to right, as in place on the board. Health is the current health of the ship. And in the constructor we only need type and whether it's vertical or horizontal. And initially when we create a ship, its health is equal to the type. So basically if it's type 5 cells, that will mean that the health will be 5 units. Method hit, we simply decrease health by 1. Now it is possible to decrease that below 0. So it is typically the logic sort of defensive programming technique is either to do this here in this method, or you can do it in your user interface. I've done it in user interface, so keeping direct methods very simple. So there's nothing else. It does exactly what it says: hit and decrease the health. Is alive returns whether the ship is alive, and it is basically if the health is greater than 0. Now we'll go to board. These are the imports that you'll need. Board is slightly more complicated. It extends parent so we can show the board. We're currently not doing anything for the ship, so we're not going to display ships just yet. You'll have each board. Actually, I'll just run the application so you can see. So this is a board, and it has rows. Each row is a vertical box. So it has 10 rows, and the rows contained in the vertical box are horizontal boxes. So there are 10 horizontal boxes within a single vertical box. This boolean is used to flag whether this board is enemy board or is our board. And then we have number of ships per board. we'll use that to determine whether we have won the game or not. So when we create, actually we'll start from the cell. So each square in the board is represented by a cell, and cell extends rectangle. XY is the position of the cell within the board. The reference to a ship is the part of the ship, or actually the whole ship, that is contained in that cell. So if a cell does not have any part of the ship, this will be null. This boolean, as the name implies, basically tracks if the cell was ever been shot. Then we have the reference to the board, and this board is the same, so basically the parent of that cell. This cell has a reference to the board, this one, and these cells will have reference to that board. We'll use that for later. So in the constructor, what we have is cell can be constructed with XY coordinate, so where it is in the board, and with a reference to the board itself. We then call the superconstructor, which is the rectangles one, with width and height of 30 units. We then set our fields, XY, board, and then we set color, fill color to light gray and stroke color to black. So as you can see, this is the fill color, and around it you'll see the stroke color. And the cell has just has one method, which is shoot. So was shot, we set it to true. We change the color of the cell to black. If ship reference is not pointing to null, so this means that there is a part of a ship in that cell. Then we hit the ship. We call this method that we already covered. We then set fill to red, so this will override this call. So we'll set it to black first, but if then ship was hit, then we set it to red. And then we check if the ship is alive. If it's not, then we reduce the number of ships for that board. And we return true to say that we hit the ship, and false for miss. Now we can go back to declaring board constructor. We take the boolean enemy as in enemy board or our board, and then we'll take a handler. This handler will be used for mouse clicks on cells. We use the same reference because we don't really want to create 100 objects per board, so we can reuse the same object because it's doing exactly the same, and each cells are, in terms of functionality, are exactly the same. So we have a for loop for 10 units. We know 10 because it is defined in the rules of Battleship, standard rules or classic rules, I'm not sure, but I just looked it up on the Wikipedia. So 10. We create a row. We then, from again 10 times, we create a cell with XY coordinate and this referring to the board. We set and must click the handler, and we finally add that to the children of the row. So we're populating the board element by element within one row, and then we go into another row. And this adds this row to the list of rows. And we do it 10 times, and hence we have 10 by 10 square. Finally, we add rows to the children, the parents, so that we can display this with JavaFX. Now onto logic. There are certain things we need to do in order to make sure that we can place ships, and well, yeah, this logic is basically about placing ships. So what we have here is method that returns a boolean called place ship. It takes a ship and then x and y coordinate of the cell. Then we call another method to check if we can place the ship. So if we can do this, we perform, so basically we execute this code and return true. If we didn't place the ship, then return false. So yeah, if we can place the ship, then we take the type of the ship and we create a local variable called length, because length we can use then to check whether we're able to place that ship where we want. Vertical is basically storing the ship vertical. Actually, we can remove that and use this directly. So if the ship's orientation is vertical, then we check y values. So we start from I and assign y to I, and then y coordinate till y plus length. So it is going to be length of the ship. We obtain cell in that coordinate for that cell. So basically cell in that xy coordinate instead of y, we're using I, because this will be incremented every time we go around the loop. And then because we can place the ship, we can now assign the same ship to the reference in the class cell, so that cell ship reference is pointing to the ship that we want to place. If you remember, this is a flag to say that it's an enemy board. So if it's not enemy board, then we set fill to white and set stroke to green. So this is what happens here. Because we don't want to place ships on the enemy board and make them visible, because we want to sort of guess where the ships are. That's the whole game, really. So if it's not enemy board, then we show ships. If it's enemy board, we do nothing. We place the ship in the model of the game, but in the view of the game, we still won't be able to see where ships are. So that's for vertical. So if we go in here, that means that ship is horizontally placed, and we do exactly the same just for x values. So we go from x to x plus length, and instead of checking x and I, we check I and y, because y stays the same. And finally, we return true if we could place the ship, and return false if we couldn't. Get cell is really simple. We just take, and there's a lot of conversion going on, because these things return nodes and we operate on our cell and hbox. First of all, we get children of the row. Basically, we get our rows. And then we typecast it to hbox, horizontal box, so that we can get so we first obtain a row from the rows, then we typecast it to hbox to get children. And then once we've done that, we get x within the row to get us the cell. And finally, we typecast it to cell and return it. Now these things are, so we do this first, can place ship, slightly longer. Again, we can use this directly. So this is the method that we call there. It again takes ship and xy coordinate of the cell. We create variable length to store length of the ship. Type is basically the length. So if it's placed vertically, then we check for all y values. and if it is not a valid point, we return false immediately, because we know that we won't be able to place it there. If it is valid, so if x, y are in the range of our board, then we obtain the cell in that coordinate. We then check if there is a ship or part of a ship placed in that cell. So if it is not equal to null, it means that the ship, part of a ship, is placed in that cell. So we return false again, saying we cannot place it there. And once we've done checks for validity and emptiness, we then go for neighbors, because you cannot place, for example, here I've placed my ship here, now I cannot place it here. Second one, if I click on it, it won't let me. You have to do it at least one block away. So we obtain neighbors of that cell, and this has to be for each neighbor, so left, right, top, and bottom. If it's not valid, return false. So this is basically the same check, and if the neighbor has a ship, then return false. The same checks are done for horizontally placed ships, except we are using x values. Get neighbors, yeah, so we create points which are going to be for our coordinates around the cell. So if that cell is 0, 0, so this cell is 1, 0, and this cell is 0, 1. So it's -1 for x, same y, +1 for x, same y. And the opposite, so we use the same x but different y coordinates. And then we place them inside an array of points. We create a list of neighbors to store these cells. So for list of points, for all 4 points, we check if they're valid. If it's not, then we don't do anything. If it is, we add a cell to the neighbors list. And we finally return the list as an array. Okay, so we've done that. Valid. So we have 2 methods. This is called method overloading, when you have 2 exactly same names for 2 methods, but different types and number of parameters. And for a point to be valid, its x coordinate must be greater or equal to 0 or less than 10, so within that range. Same applies for y coordinate. It has to be greater or equal to 0 or less than 10. So this is 0, 1, 2, and so on until 9. And when we call this, it simply delegates to another method, which is this one. So we've covered the class board pretty much. And yeah, don't worry, the code will be online, so you can download it. You don't have to type it as you go. Battleship main is the main application that uses JavaFX platform. As always, we have main that launches the application. These are the imports you'll need. First of all, let's cover fields. So running. This is not as the game running. This is more of a state, like if running is false, that means that you're placing ships now. If running is true, then you have finished placing ships and you're now playing the game. References to enemy board and player board. Ships to place is number of ships you have left to place. This applies for like beginning of the game. Enemy turn, just like it says, where it's currently turn for enemy to move. And reference to random. We could use this or math.random, doesn't really matter. Yeah, we'll just start first. As always, we have a scene. We create content for the scene. which returns the route for the scene. We set title, Battleship, or whatever you want to call your game. Scene resizable false. We don't want the user, the player, to be able to resize the window. So as you can see, there are no ways of resizing it. And finally, we show the stage. So if we do create content, so it's this. So far we've been using panes, just panes, because we wanted to place things manually. But I want to show you how powerful JavaFX layout methods are, or layout techniques. So this is one of them, is border pane. It has 5 places to place items. So this is the top side. Then it has a left, center, right, and then bottom. So if some of the places are unoccupied, then they'll be sort of combined with other places. So say we're going to use right side, which is going to be sidebar for our controls. We'll probably do controls in a different tutorial. And this is going to be our centered node, if you want. So we set preferred size 600 to 800, so vertical orientation. You could do horizontal one as well, so place 2 boards on the same line. So these are our handlers for boards. So if we, let's do them one by one. Any board, new board, true to say that it is an enemy board. Then we supply a handler, which is here. So it can be any handler that is a child of mouse event or inherited from mouse event. So it could be any mouse event basically. And we're really just waiting for click because we set mouse clicked. Again, you can use lambdas if you want. It's just easier to define this way. So enemy board, if the game is not running, then return, because we don't want to do anything before the game starts on the enemy board. Then we obtain the source of the event, which is going to be the cell on which the user has clicked. We get the cell reference. If the cell was shot already, then simply return. We have nothing to do. Enemy return. Okay, we now shoot the cell. So there's quite a lot of things going on there. We shoot the cell. We get the result from the shot, and then we assign not to that result. We sort of negate the result and then assign it to enemy turn, which this is like an assignment with a side effect, I think it's called. So the shoot is here. It returns true if we shot, if we got a hit, and if we got a miss, then it returns false. So it returns true, then we got a hit. We then negate that. That will become false, and then we set false to enemy turn. So enemy cannot move now because we scored a hit, and we can now shoot again, and vice versa. So if it returns false, then this becomes true, and we set true to enemy return. So enemy can now move or make move. If number of ships on enemy board is 0, then just print that you won and end the game basically. So you can even sort of exit because there is no point. Well, actually, you won't see the. Yeah, just leave it there. So if enemy turn, then enemy move. Actually, no, you have to sort of exit the game because otherwise it'll just keep moving. You don't have to really do this, but you can put something like, do you want to restart the game or something like that, because at this point the current instance of a game has been completed. Yeah, we might do that in the next tutorial, have controls and stuff, so the player is able to restart the game and play another round or something like that. So if enemy turn, then make enemy move. Player board is a bit simpler. It is false to state that this is not an enemy board. It also takes an event, which is the event handler for the cells on the player board. If the game is running, then return, because we don't want anything to do with the player board while the game is running. We obtain the cell, which is the source of the event, and we then check if we can place ship here. So we create new ship with the type, so that's ships to place, and this will be decreased every time here. We check the button, so if the button is primary, so basically left click, then it will automatically do a vertical. Or if it's not left click, then it will place the ship horizontally. And then we pass two values, x, y, values of cell x and cell y. If we place the ship, then we first decrease number of ships. This is again assignment or check with statement with side effect, because we decrease the ship and then do a Boolean check in the same statement. So we decrease number of ships to place, and then we compare it to 0. If number is 0, then we start the game. A thing to note here that you cannot you have to do minus minus in front of the ships to place, because this will decrease this variable first and then do the checking. If minus minus was after ships to place variable, then it would use the variable as it is, the value of the variable as it is now, then check it against that, and then decrease it. So it's not what we want. And so basically, if there are no more ships to place, then start the game. Finally, a vertical box, 50 units is the difference between elements, or the distance between elements, so it is between two boards. We place enemy board first and then player board, so they're in vertical orientation, vertical layout. We set alignment to center, so it is centered within the space available. And finally, we set center vertical box to the root. And this is the text on the right side. So you can play with it. You can add another vertical box here and certain controls if you want, or even text messages. So this would be one way of extending this application. Enemy move is a while enemy turn, take random x coordinate, take random y coordinate, and obtain the cell in that player board. We don't really need to check whether this cell at this point is valid or not, because we know that this method will return a value between 0 and 9, 9 inclusive, and 10 would be exclusive. If cell was shot, then continue, because we want to select cell that hasn't been shot yet. Enemy turn then is assigned cell shoot, so if the enemy hit part of the ship, then it will be assigned to enemy turn, so you can move again, otherwise it will be assigned false, so this thing will be false and while loop won't be run second time, won't run for second time. If player ships, if the number of ships on the board, player's board is 0, then print you lose, and possibly exit the game. You don't really need to type that. It's just for me to think about for our next tutorial. And start game, we just place enemy ships really. We start from 5. While the number is greater than 0, we obtain random XY coordinates. We try to place the ship in there. If we succeed, then we decrease the type, and this goes on number of times needed to place 5 ships. And a vertical ship is placed if this random returns less than 0.5, and if it doesn't, then it will use horizontal orientation. So it's almost like 50%. And finally set running to true to signify that the game has started. So you can make ships touch, I think. I don't know if it's allowed by the rules. If it's not, then you can just do this type of check on the corners. So now that I've placed all my ships, the game can now start, and we fire things one by one to get ships. As a possible extension, you could also mark like cells around the ship that has been destroyed completely to make sure that the player doesn't click on it, because there's no way that there could be a ship in that cell, for example, to sort of space, to save the space. And when the enemy will hit the target, he'll automatically do another move, and so on. Oh yeah, another extension could be to come up with a better AI, because our AI is basically selecting random cells and then shooting them. That's it. And a bit smarter AI might try hitting cells near the cell that contained the ship just now. And yeah, so that's it for this tutorial. Next tutorial might be on this Battleship game as well. So I'll have a look. I'll definitely put up a link because there's a lot of code to cover. And thanks for watching.